Hi, welcome to my video on graphs of equations. I'm going to focus on two basic equations here. We got our proportional relationships, y equals kx, and my example of y equals 2x, and the non-proportional relationship, y equals mx plus b, and I'll explain the differences between them. So let's start with the proportional relationship. And a proportional relationship means that the fraction of the y value to the x value is always the same. So the classic proportional relationship is y equals kx. K is known as our constant of proportionality. In this case, it's 2. So everything gets scaled up 2 times. And if I start in with a set of x and y values, so we can have x and y, and I'm going to make a little table. Weird squiggly lines there. So a table. So the x values can really be anything you want them to be. I'll just choose some easy ones, starting with some negative values like, I don't know, negative 3. I'll go on to negative 1. I'll do 0, 1, and I'll even do 4 there. So these are just arbitrary, random x values that I'm choosing. But now the y values have to be very specific. See, the rule here, our equation or our rule is the y values are 2 times any x value. So that means that over here, it's going to be, the y value is going to be 2 times, in this case, negative 3, because x is negative 3. And that means it's negative 6. The next one's going to be 2 times our new x value is negative 1. So that means it's negative 2, because 2 times negative 1 is negative 2. And then it's going to be 2 times 0. That's easy. That's 0. And then we have 2 times 1, which is 2, and 2 times 4, which is 8. And so what we have here, and I think I'm going to move this over a little bit. So what we got, I moved it over a little bit, and let's do it. Let's condense what we know here. We know that the x value is negative 3 and the y value is negative 6. So I'll write that as what's called an ordered pair. So we have negative 3 comma negative 6, and there you go. There's one ordered pair. That's just taken right from our information here, negative 3, negative 6, and I just put them together. Okay, it'll make sense in just a moment, hopefully. And then the other ordered pair is negative 1, negative 2, and then we have 0, 0, and then we have 1, 2, and then 4, 8. Now, all of these ordered pairs can be graphed on this coordinate plane here. And let's see if I can slide these down here. So the first one I'm going to do is negative 3, negative 6. So negative 3, negative 3, negative 6 goes, what? You start in the middle and you go negative 3, and then negative 6 goes down here. And a dot needs to be placed right there, which I will do right now. That point is negative 3, negative 6. And then we have more here. So the next one on our list is negative 1, negative 2. I'll place that what? Negative 1, negative 2 is right here. And I'll put an ordered pair. Right? I'll write negative 1, negative 2. And then 0, 0. That's easy. 0, 0 is right in the middle. 0, comma 0. And 1, comma 2 is the next one. 1 on the x and 2 on the y. Okay. 1, comma 2. And then 4 comma 8, 4 on the x, 8 on the y. Oh, that's going to be off 6, 7, 8 is about there. So 4 comma 8, I should have thought of that ahead of time, is about right there. 4 comma 8. And you might notice right now that there's a pattern. It makes, they're going up in a line. And in fact, we can put a line to this, and I'm going to do that right now. I'm going to line this up as carefully as I can. And I'm going to draw that line, and it goes right through all the points. And that is definitely done on purpose. And in fact, this blue line represents all of the ordered pairs that work in our original equation. Remember, our original equation is y equals 2x. So, I mean, there's other ordered pairs here. For instance, I can see that there's an ordered pair right here of 2 comma, that location is 2 comma 4, and that should make sense because 4 is twice the size of 2. So let's go back to the idea of a proportional relationship. In a proportional relationship, you have you have y equals k times x, and where that constant proportionality is the y value divided by the x value. Now, if we take any y value and divide it by any x value on this right here, check out what happens. 8 divided by 4. That would be 8 divided by 4. That's 2. Or this other one down here, 2 divided by 1. You have 2 divided by 1. That's also 2. You can even take this one on the bottom. Negative 6 divided by negative 3. Negative 6 divided by negative 3, all equal to 2. And in fact, in my class, we talked about the slope. The slope is the rise over the run. And what that is let's zoom in on a little part of this, like this part right down here. The rise is how far you're going straight up. Well, let's see, you go up 1, 2, 3, 4. You're going up 4. You're going up 4. And then the run, okay, so rise is 4, and the run is 2. You're going to the side 2. Up 4 over 2. Hey, 4 divided by 2 is 2. So, an important idea here that's happening is when you have a proportional relationship, the y value is always, the y value divided by the x value is always the same. It's going to make a straight line. Any proportional relationship, when you graph all those ordered pairs, can make a straight line. It's going to pass through the origin as well. And also, what's hiding in this every time is when I see y equals 2x, that coefficient, the coefficient is the number in front of the variable. In this case, the coefficient is 2. The coefficient of x is also the slope of the line. Every time, in every proportional relationship. So to recap, in proportional relationships, propor and AL, one, y value divided by x value is always the same. It's a straight line that passes through the origin when graphed. Okay, so that's another thing that happens in proportional relationships. And probably another great number 3, in y equals kx, which is this general form for any proportional relationship, k is the slope. And the constant of constant proportionality. So this ties in so many ideas. The primarily, I wanted to connect. And let me erase some of this stuff here because, you know, a lot of stuff got mixed up in here. But what I basically wanted to do, the main goal was I wanted to connect the equation. How does this equation what is the connection between the equation and the line? And I hope that you can understand that the line is made up of all of these points, and the points on the line end up being ordered pairs that satisfy this equation. For example, like I said, 1 for x, and you'll get 2 for y. So 1 for x, 2 times 1 is 2 for y. That happens with all these ordered pairs. Now, let's go over to the non-proportional relationship. So take a look at this. We have y equals kx, and we have y equals mx plus b. And these are very similar here. You have the k and you have the m. You have an additional b there. I tried to make these pretty similar too. Y equals 2x, and then this is y equals 2x plus 1. So I'm going to erase this stuff and get this ready for you. So what I did is I made another table of values, or a table ready for some values. And again, you can choose any x values you want. It really is not going to matter. We're just going to choose a few samples. So I'll choose a couple of negative samples. I'll choose 0 and a couple of positive samples. Like negative 3 is pretty good. And so what would that mean? So our new rule now is this: 2 times x plus 1. So the x value is negative 3. So 2 times negative 3. That's what it's going to be. It's going to be 2 times negative 3, but now I got to add 1. And what is that? Negative 6 plus 1 is negative 5. And so our ordered pair now is negative 3 for x and negative 5 for y. And then I'll choose negative 1 for x. So that means it's going to be 2 times negative 1 now, plus 1. 2 times negative 1 is negative 2, plus 1 is negative 1. And so our order pair is negative 1, comma, negative 1. And I'll choose 0 because that's easy. 2 times 0 now, plus 1 is just 1. So that's 0, comma, 1. And then I'll choose 2. 2 times 2 plus 1, that's 4 plus 1 is 5, so that's 2 comma 5. And I better just go with 3 here. So 3, 2 times 3 plus 1, that's 6 plus 1 is 7. So that's 3 comma 7. And so I've done this here, and I can plot these ordered pairs just like I did before. I'm going to bring this up. I got to erase a little bit from that last one there. And I'll just go in with this first one, negative 3, negative 3, negative 5, negative 3, negative 5, negative 3, negative 5 is here. I don't think I'm going to label it. Negative 1, negative 1, negative 1, negative 1 is here. 0, 1, 0, 1 is here. I'm looking at 2, 5, 2, 5 is here, and 3, 7, 3, 7 is here. And once again, there's that straight line looking at us right there. And I'm going to draw a line through that. And boom. So there. That's red this time. You know what? I'm going to undo that. I want it to be blue because I'm kind of used to that being blue. Okay, so now I have this. Now I'm saying, okay, another great thing to say about this is it is linear. This is linear, which means it's a straight line. So later on, you'll learn about nonlinear graphs and equations, and that means they don't make straight lines. But right now, it's linear. And the slope. Now I'm going to bring this into play now. This part right here, y equals mx plus b. M right here is the slope, and the b is the y-intercept. So the y-intercept, that is telling you where it crosses the y-axis, and it crosses the y-axis at 1. And sure enough, look at that, it crosses the y-axis at 1. The slope in this case is 2. And slope, which is called m for some strange reason, is 2. And let's make that a fraction. which tells us our rise over our run. So the slope is 2, or up 2 over 1. That means that I'm going to go, let's zoom in here. That means that slope is going to be up 2 over 1. So I can choose any 2 points. Let's go with right here. I'm going to go up here. So how far did I go up from one dot to the next? I went up 1, 2, 3, 4. I went up 4. So I go up 4. And how far did I go straight to the side? That's called the run. I went to the run 2. So that is, so then the slope, I'm trying to think of a place to write it. The slope is up 4 over 2, which equals 4 divided by 2 is 2. And there proves that, yes, that slope is of the line is in fact 2, because hey, it's right there. It's the coefficient of x is the slope. And it doesn't matter what 2 points you choose. You could have chosen these 2 points right here, and you just see, you go up 1, 2. There's the rise of 2 and the run of 1. Rise 2, run 1, slope of 2, same thing. And so I'm hoping that you can see. Now, what makes this non-proportional? If you remember over here, a proportional relationship such as this one, every y value, let me zoom in here. Every y value divided by the x value was the same. 4 divided by 8. I'm sorry. 8 divided by 4 is 2. 2 divided by 1, except for the 0, 0. It always passes through 0, 0 every time. And the negative 2 divided by negative 1 is 2. Negative 6 divided by negative 3 is 2. But in non-proportional relationships, the y value divided by the x value is not always the same. So take a look at this. We take our y value. So I'll say here, the y value is negative 5, and the x value is negative 3, and that is 1 2/3, which is 1.6 repeating. Okay, I can take the y value here divided by the x value here, and that negative 1 divided by negative 1 is 1. Here, the y value would be 1 divided by 0. That's undefined. That's not even, I mean, look at this. We're getting three different values right here for the y value divided by the x value. That's why it's not proportional. Because if I continue here, the y value divided by the x value is, what, 2.5. Again, and then what? That's going to be 7 over 3, which is 2 1/3, which is 2.3 repeating. That's what happens when these non-proportional relationships is the y value divided by the x value ends up changing wherever you are. But what is always the same, though, is that slope. The slope is the same, and that's okay, but our y value divided by the x value is different. And so in non-proportional relationships, so I'll summarize this. Non-proportional one, the y divided by the x is always different. Number 2, y equals mx plus b. This is the y-intercept, and this is the slope. Number 3, it is linear, which means the slope is the same throughout the line. So we have a lot of stuff here, and there's one more thing I want to mention here is when we look at let me write them here again. We have the y equals kx, and we have the y equals mx plus b. Proportional and non-proportional. This was the slope. This was the slope. Okay, and so that's pretty cool. And this is the y-intercept. You know, y equals kx would work too, because we could say y equals kx plus 0, and now it would look a lot like the y equals mx plus b, because y equals kx plus 0 means it would start at the origin, and then the slope would be k. So this still has room to kind of look like a non-proportional relationship, but the problem is now once we start adding or subtracting something, we move off the origin and we're starting somewhere else on the y-axis, and it's not proportional anymore. So I'm hoping that I've gained some insight on this. This is heavy stuff. When we're talking about graphs of equations and we begin with the proportional relationship as the most basic of them, and then move on to these non-proportional relationships with the y equals mx plus b, which is called slope-intercept form, things start to get a little wonky. So thanks for watching, and I hope this has been helpful. Bye.